All right, in this video, we're going to be practicing integrating quotients, all sorts of integrals that have fractions in them. And so a lot of them are going to be partial fractions, but then we also have some that we need to hit with algebra and some other stuff. So we're going to start off with 1 over x squared plus 5x plus 4. There we go. And that is going to be, I'm going to do the work on the fraction itself first. So I'm going to say 1 over, I can see that that's factorable. That's x plus 4, x plus 1. That's going to be some number divided by x plus 4 plus some other number divided by x plus 1. Okay, then I'm going to multiply both sides of this equation by both denominators, and I'll get 1 equals a multiplied by x plus 1 plus b multiplied by x plus 4. Okay, I'm going to let x equal -1, and that's going to give me 1 equaling 0a plus 3b. So b is 1/3. And then I'm going to let x equal -4. That's going to give me 1 equals -3, not b. b 1 equals a times -3 plus b times 0. So that means a is -1/3. Okay. So now I'm actually integrating a was -1/3 divided by a1 over x plus 4 plus 1/3 divided by x plus 1. Okay. Now, if we want, we could factor out the 1/3 to the front, or we could just say this is going to be -1/3 natural log absolute value x plus 4 plus 1/3 of the natural log of the absolute value of x plus 1 plus c. You can combine those using log property if you want, but that's not necessary anymore. So I'm going to stop there. Okay, the second one is the integral from 3 to 4 of x over x squared minus 3x plus 2. So I'm going to do the work on the fraction itself. So x over x, that's going to be x minus 2, x minus 1. It's going to be some number over x minus 1 plus some other number over x minus 2. All right, so I'm going to multiply both sides of the equation by both denominators, and I'd get x equal a multiplied by x minus 2 plus b multiplied by x minus 1. And I'm going to let x equal 2, and that would give me 2 equals 0a plus 1b. And if x equaled 1, I would have 1 equaling -a plus 0b. Okay, so that means a is -1. All right, now, I could write -1 over x minus 1 plus 2 over x minus 2, and that's going to be the exact same, but I think I might write it so that the minus sign's in the middle. Okay, and then I'll say, all right, now I'm integrating from 3 to 4. I haven't changed the variables or anything, so it's not going to change the balance. 2 over x minus 2 minus 1 over x minus 1. Okay, and I'm going to get an antiderivative. Minus 1 natural log of the absolute value of x minus 1. And let x run from 3 up to 4. Okay, so when I plug in x equals 4, I would get 2 natural log 2 minus the natural log of 3. And when I plug in x equals 3, I will get 2 times the natural log of 1, which would be 0 minus another natural log of 2. Okay, so I'm seeing 2 natural logs of 2 plus another natural log of 2 is going to be a 3 natural logs of 2 minus a natural log of 3. I think that's what it would look like if this was a multiple choice question, what the correct answer would look like. But I will also point out that, we could apply log properties and write that as natural log of 2 to the third divided by 3, so that would be 8 thirds. Okay, number 3 is just an antiderivative, but the denominator's already factored, so I know it's factorable, and it says use partial fractions. So x minus 16 divided by x minus 2 and 2x plus 3. I don't like the look of this, but okay, whoops. 2x minus 3 and x minus 2. So that's going to be some number divided by 2x plus 3 plus some number divided by x minus 2. Alright, so I'm going to multiply both sides of the equation by both denominators, and I'll let x equal 2 and get 2 minus 16 is negative 14 equals 0a plus, wait, what? 4 and 3 is 7b. Okay, yeah, that makes sense. So b is negative 2. Now, we could use x equals negative 1.5, but I think you could also use x equals 16, knowing the value of b. I mean, yeah, knowing the value of b. That's, yeah, totally up to you. You could use x equals negative 1.5 also. But negative 1.5 minus 16 more is negative 17.5. I don't, I'm trying to think. Yeah, I'm going to do x equals 16 because it's something different. Okay, so that would be 0 equals 14a plus negative 2 times 2x plus 3. Okay, 32 and 3 is 35. Oh yeah, see that factor of 7 in there. Okay, it's going to work out. I put all the fractions together when I was making the homework, so I know it's going to be mostly integers, or at the very worst, like nice fractions. So I've got 70 equals 14a, and that will mean that a needs to equal 5. All right, so 5 and negative 2. So I'm integrating 5 over 2x plus 3 minus 2 over x minus 2 with respect to x. Okay, now I have to be very careful about this one right here because of that 2x. Okay, we're going to need to remember that, think about the chain rule there. When I anti-differentiate, I'll still be thinking 5 natural log of the absolute value of 2x plus 3, but I'm going to need to divide by that 2 to prepare for the chain rule. Okay, minus 2 natural log absolute value x minus 2 plus c. Okay, number 4 is going to be the, okay, oh yeah, it's factorable, t times t plus 1. Okay, didn't see it, t plus 2 divided by t, and t plus 1 is going to be some number divided by t plus some other number divided by t plus 1. Okay, so I'm going to say t plus 2 equals a multiplied by t plus 1 plus b multiplied by t. And then I'm going to let t equal negative 1. I'd get 1 equals 0a minus b. Okay, and then if t equals 0, I would get 2 equals a times 1 plus b times 0, so a equals 2. And so now I'm integrating from 1 to 10. 2 over t minus 1 over t plus 1. An antiderivative for 2 over t with respect to t would be 2 natural log of the absolute value of t minus 1 natural log of the absolute value of t plus 1. Let t run from 1 to 10. All right. So I think like 1 to 2 would have been a little bit more interesting, but that's all right. So 2 natural log 10 minus natural log of 11 minus 2 natural log of 1 is 2 times 0 minus natural log of 2. Okay, so that's going to be 2 logs of 10 minus a log of 11 plus a natural log of 2. I think that's what the right answer choice would look like if it was multiple choice, but if you wanted to combine this with log properties, okay, 10 to the 2 is 100, multiply that by 2, that would be 200 divided by 11. Okay, number 5, x plus 2 over 2x squared minus 3x plus 1. Okay, that's going to be factorable. And, you know, I mean, it's possible, it's probably unlikely that you would need to factor this one yourself in AP Calculus, but we need to be able to. And this one, I think you can probably, you know, do this one just by looking at it. But in case you can't, in case you're not seeing the factors, I would recommend just being like, okay, 2x squared, you get that from 2x and x, and plus 1, it's either going to be minus 1, or plus 1, plus 1. I feel like minus 1 and minus 1 is going to be the way to go, and then you check, and it's like, okay, yes, I do get negative 3x that way. Okay, you can do that, or you can say, all right, two numbers that multiply to 2 and add to negative 3 are negative 2 and negative 1. And then you split the middle term into those and group and factor, which is much more reliable than guess and check, in my opinion, so I just feel like I'm kind of obligated to remind you of this, especially if you were in my Algebra 2 class 2 years ago. You know, we did this quite a bit. Maybe I factored out a negative 1 there, and then I have x minus 1 I can factor out, and I'm left with a 2x and a negative 1. There you go, that's how it goes. But if you can see it, just you don't need to waste your time doing that. Okay, so I determined that was the denominator, and the numerator was x plus 2. That's going to be a divided by 2x minus 1 plus b over x minus 1. And multiply both sides by both denominators and get x plus 2 equals a multiplied by x minus 1 plus b multiplied by 2x minus 1. Alright, now I'm going to have x plus 2 when x equals 1. 3 equals 0a, 2 minus 1 is 1b. Cool. And then x can equal 1/2 to make this thing right here equal to 0. And that will give me 1/2. 2.5 is 5/2 equals 1a times 1/2 minus 1, so that's negative 1a, so a must be negative 5. And I'm integrating this from 0 to 1, so integral from 0 to 1 of a is negative 5, so maybe I'll put that one second. Minus 5 over a went over 2x minus 1. B was 3. That goes over regular x minus 1. Okay, so once again, I'm going to need to be careful on that term because of the 2x there. So I'm going to get my antiderivative, and I'm going to say that's 3 log absolute value x minus 1 minus 5 log absolute value 2x minus 1, but I'm going to need to divide by 2 there to appease the chain rule. I'm going to let x run from 0 to 1. Oh no, 1 was a bad choice there. I'm going to need to change those bounds. Alright, that will work much better from 2 to 3. Just think about that too much. I think negative 1 to 0 would have been kind of a similar situation, but I'm going to do from 2 to 3, and I'm going to say, all right, that's 3 log 2 minus 5/2 of the log of 5. This one I will not be simplifying. Minus 3 log of 1 minus 5/2 of the log of 4 minus 1 is 3. Yeah, that's 3 different types of log there. Okay, I think that's simplified enough. Now, number 6 looks like it's gonna be a little nicer. Okay, so 4x plus 6 over x plus 4, and 1 minus x is going to be a divided by x plus 4 and b over 1 minus x. That means 4x plus 6 equals a multiplied by 1 minus x and b multiplied by x plus 4. And I'm going to let x equal 1. And that would be 4 plus 6 is 10 equals 0a plus 5b. And if x equals -4, I'd have -16 plus 6 is -10 equaling 1 minus -4 is 5a. So that's going to be a equaling 2 also. So I'm going to be anti-differentiating 2 over x plus 4 plus 2 over 1 minus x. Okay. And because 1 minus x does not have a slope of 1, I need to be careful on a chain rule level there with that negative x. Remember to divide by -1 to appease the chain rule. So I've got 2 natural log absolute value x plus 4 plus 2 natural log absolute value 1 minus x divided by -1. So I'm going to be subtracting there. And add a plus c. And if I wanted to simplify that with log properties, which you definitely don't have to, you would divide the arguments.